with a little bit larger angle top right here. So you can actually do a lot of different things, depending on your application with the need, right? So these are the some theory behind the spline curve. Again, first introduced by Beizier, the spline curve. And why don't we solve one problem here to show you how we apply this here in actual problems. Okay? So any question before we actually move on to the actual problem?
What is P?
What is what? P right here?
Yes.
These are control points. For example, if you have so P naught could be, for example, like 1, 1, 1. This could be your P1, P2, P1 could be whatever control point that you clicked on the screen. So these values will go into these equations and multiplied by this priming function, and then the propagate through to get the final result. Yes.
And then for the blending function for 0,
Yeah.
Won't you get a 0 in the denominator?
Is it right here?
Yeah.
So we're going to go through one example, but the 0, what is it? 0 factorial?
0?
1. That's 1. It's defined as mathematically it's defined by 1. So there's no 0 in the denominator.
Okay.
But again, we're going to go through one example. Okay. Other question? No? All right. Let's solve one problem here to show you how this will be useful. So I got one problem with the 4 control points. Okay. So let's just try to develop first of all the blending function first, and then I'm going to show you how do we utilize this blending function to propagate this through the final result, final equation. Okay. With actual some number in the point or the points. So n here, if I have 4 control points, what is my n value? 3. And then my j should be starting from what? 0, 1, 2, 3. So the number of parameter j is going to be equal to the actual number of control points. Okay? Although the parameters start from 0, ending n minus 1. Right? So if that's the case, your B, first B should be 1 now. Let's just write B here somewhere. So we get right? This is a different B. I'll just go with the Beizier spline curve B here. One more time. So B and J. Again, 0 factorial is 1, okay? Just for your refreshing your memory from elementary school math, right? So B, what is going to be the first B now by using this n and j? B, n should always 3. J should be starting from 0. So 3, 0. Okay, that's your first B. So B 3, 0 should be equal to 1 now. Let's just substitute the values into these parameters. N, 3, factorial, and then S is parameters changing from 0 to 1. So the thing is, if you have control point like this, unlike the A-spline curve, the B-spline curve will basically change it from 0 to 1. This is the first control point, and the 1 actually stands for the last control point. It's not like 0, 1, 0, 1, 0, 1. Okay? In our A-spline curve, it's changing from 0 to 1, 0 to 1, 0 to 1, but it's not going to be like that. It's just starting from 0, which is starting first control point, P0. This is P3. Starting from 0 to 1, that's your S. This is your S. Okay? That's one difference. So, S to the 0, the S, J is 1 now. Right? J should be 0, 1 minus S. N is what? 3 minus 0. Okay? And then in the denominator you have a 0 factorial. N is 3 minus 0 factorial. Okay? Now if you look at this equation, there's a 3 factorial, so you can cancel these now. Correct? What is the S to the 0? 0. 1. This is 1. So, and then this has to be 1. This has to be 1 also. So this equation should be 1 minus S to the cube. Right? This cube. Now, the second one, just do the same thing like this to figure out all the Lemming functions. So what is the second Lemming function? B? Huh? 3, 1. What is B 3, 1? How do I make it? Still 3, right? 3 factorial. Then 1. What is S? S still there. J? J is what? 1. 1 minus S times what? 3 minus 1. That's your numerator. Denominator should be J. J is what? J is 1. So 1 factorial. And then N is 3. J is what? 1. Okay? Make sense? So 1 factorial is 1 again. And then the if you look at this, what is this?
That's 3 times
2 factorial, right? 2 factorial. And then this guy is always 3 factorial is what? 3 times?
3 times 2
2
factorial.
factorial, right? 2. So I can cancel this out. And I have 3 left over. So this must be 3 times S times 1 minus S1 squared. How about this guy? This guy is already taken into account, right? Taken into account. Now, what is next? My next B? B? 3, 2. Again, so substitute those parameters into this equation. So 3 factorial, and then what?
S squared.
S squared. 1 minus S. 1, right? 3 minus 2. It's 1. And then the denominator J is what again? 2 factorial. N is 3. 3 minus J is what? 1 factorial. Right? Now this will be, again, 2 factorial. 3 is 3 times 2 factorial. So these will cancel each other. So 3 times 1 now. 3 times S squared times 1 minus S. Right? 3 times. Pretty easy, right? Any questions so far? I think I could teach this to my nephew, 4 or 5-year-old. If they know, understand this factorial and then the 0 factorial as well. Anybody can do it. So that's what is the next one? The last one, B. 3. 3. Let's try this out. 3 factorial and then what? S cubed minus S. 3 minus 3, 0. And then J is 3 factorial. And 3 minus 3 factorial. So 3 to the curve, these two each cancel each other. This is a 1, so it should be what? S?
Cube.
S cubed. S cubed. So I found all these blending functions. Okay? All four blending functions. 1, 2, 3. So if you have a 4 control points, you have 4. If I have 10, you have develop how many? 10 blending functions. Okay? 10. Now, so once I develop all this blending function, now it's time for me to put them all together with the summation. What was the summation equation? So RS should be, RS will be sigma blending function NJ times P, PJ, J is changing from 0 to 0 to, that's your blending function. That basically is the equation that your final Beizier spline curve, right? Final Beizier spline curve. So what's going to happen is, for example, let's say if I rewrite this again, it's going to be like X, Y, Z, S, S, S. X, Y, Z, J. Okay. So this will be, so if I just write equation for X, when J is 0, your blending function first one goes in there. So it has to be 1 minus S cubed times what? X. Has to be X 0. Because first J is 0 plus 1 now. Plus B, second blending function B, when J is 2 now, it should be the second blending function 3 times S times 1 minus S squared times 1 now. X 1. X 1. Plus the third blending function is what? 3 times
S squared.
S squared times minus S times what now?
X2.
X2. X2. Okay? X2. And then what now? Plus? The last one is?
S cubed.
S cubed times X.
X2.
This is the last control point. Pretty easy. So if you change the S value from 0 to 1, what's going to happen is, for example, this is your XY shape, XY plane. From S, when S is 0, you start from here, and it changes all the way up to the point of S is equal to 1. Okay? So you will obtain this control point right here. As you change your S. If your S is changing from, for example, by, if you set S incrementing by 0.1, how many points do you will obtain? 10 points, right? But if you want to obtain more accuracy, more resolution, you change this 0.01 or 0.0001, you will have a much more control point. That's how computer actually generate a lot the spline curve on the screen. All right? Make sense? So you can do the same for Y and Z. Y, just same equation, but you replace X to Y. For Z, you just replace X with Z. All right? That's how we do. Pretty straightforward, right? So if you go to the, if you go here at the blackboard, you will have the homework file right here, and use this Beizier spline curve. For the homework, just try to use this Beizier spline curve template. But if you want to develop your own, just go for it. It's up to you. If you want to use it, that's fine. So here, as you can see, this here, FACT is factorial. All this equation is just blending function. Okay. And then this x right here is your r. So this guy is going to be blending function times the first control point, which is this point. This x, y, z. The second control point right there, P2. Third one is 891. Okay, all just multiplied by this summation equation right there. Okay? Make sense? So try to use one of those, try to use this template, or if you invent your own. Solve the problem 4.8 and 4.9. So both of these you have to verify and print out your Excel spreadsheet, attach them to after you solve for the actual spline curve equation, and then you add these up. If you use this one, then you will see the chart is coming just like this. That's a smooth spline curve, okay? Projected on x, y, y, z, and z's, right? Make sense? That's the homework for the spline curve. And then that was the pretty much all of them that I wanted to cover for the spline curve, and then we'll move on to surface. Okay? Surface is a little bit complicated, but it's all based upon this theory, right? So